Okay, let's start with a problem in phase diagrams. This is a question on an iridium osmium system. The question is to make phase analyses of a 30% osmium alloy with iridium at 2600 degrees C, 2665 degrees C plus a little bit higher than that, and at 2665 degrees C and a little bit lower than that, minus delta T. That's the question. So how would you how would you even tackle this problem, right? You need to know what is phase analysis, right? So what is phase analysis? It means the question is asking you to do four things. How many phases are there? Types of phases and how number and type of phase. Composition of each phase. Amount of each phase in percent. And you are asked to draw the microstructure of the phase. So let's take a look at the phase diagram itself. Let's put it right there, and I'm going to fix it so the damn thing doesn't move. Okay, I want to fix it here so there's no movement. Great. So now, so this is the iridium osmium phase diagram. 100% iridium on the x-axis, 100% osmium on the right side of the x-axis, and the axis itself is percent osmium. Okay, don't confuse that with iridium. It says iridium and it says 10 here. It's not 10% iridium. It's osmium, 8% osmium. So careful about that. The y-axis is temperature, centigrade, Fahrenheit, centigrade, Fahrenheit, blah blah blah. Right. The first time you look at a phase diagram, you know what to do. Look at the edges. Iridium. You're just taking some solid iridium and heating it, and at that temperature it melts and becomes liquid after that. Similarly, you take osmium metal and start melting it, heating it, and at that temperature, 3,333 degrees centigrade, it melts, right? So those are the two edges of the phase diagram, which is great. Now the question is, and then of course at any intermediate composition, it melts over a range of temperatures and composition. So that's from the cooling curves, the phase diagram has been built. Okay. For example, at 30%, if you heat it, it goes through a phase, a region where there are both liquid and solid phases, right? So it starts from here, it's solid, and transitions to a liquid plus solid, and then it goes to liquid, right? Unlike the edges, which go straight from solid to liquid. Anyway, that's it. So now let's tackle the problem. What is the composition? Phase analysis at 30% osmium alloy. So 30% is right here, right? I mean, let's draw it. Okay, let's try to draw this. Let's put a decent color. And that's 30%, right? At what? At 2600 degrees, right? At 2600 degrees. 2600 is here. So let's draw that intersection, right? So you're asked to do the phase analysis at the intersection. Okay. First question is how many phases and type. Okay. Let's do it. 2600. Let's see if we can attack it. Phases is what? Liquid and alpha, right? So you have a liquid phase and a solid phase. Obviously, alpha is iridium, right? Great. What's the second one? Composition of each phase. And you know how to do that, right? You take, how do you calculate the composition of the liquid phase? Liquid is here, right? Solid is here. This is alpha. Right at the intersection line. The alpha, the solid is on this side. The liquid is on this side, where this line crosses the liquidus line, right? This is the liquid phase, right? Right. That's the composition of the liquid phase. So you have to take a walk. You walk from here all the way up to here, where it crosses, right there, around there, and you drop and you look down, right? Approximately, let's call it 16%, right? Composition, 16%. What's the composition of the alpha phase? Again, you start walking all the way to that side where it crosses that line, right? And you drop down, right? That here, this region, about 38%. 38% what? 38% iridium, right? That's the composition. Great. Now, third good question is what? Amount. Amount is what? The lever rule, right? Use the levers rule or the lever rule, whatever. So if you want to calculate the composition, the amount in the liquid side, what you do is you look at the opposite side. Remember? Important to know that. You look at the opposite side. If you want the composition on the liquid side at this exact intersection, you look at the opposite side. You measure this distance, right? And divide it by the full distance, right? Divided by that distance. That's the composition of the liquid, which is what? 38 minus 30, right? Divided by 38 minus 16, which is 36%. And similarly, the composition of the solid is when you start looking at it from here, it is, it would be this distance, right? This distance divided by that distance, right? Would be the composition of the solid alpha phase. And that would be 30 minus 16, 38 divided by 38 minus 16, right? The denominator is the same in both cases, and that is 63.6. You can always get the alpha phase by subtracting 100 from 36.4 from 100, right? You get that. That's the lever rule, right? This is the lever rule. That's that. What about the next one? 2665 plus delta T. Phases, composition, amount. What is 2665? Thankfully, it's all drawn there anyway for you, right? 2665, but it should be at 30%. That's the problem, right? Right there. That's 30%, correct? Where it crosses. So that intersection is what's being asked. So how many phases? Anybody? Can you think about it? What are the phases here? Liquid, and then what? Beta, right? You're here in this zone. Liquid plus beta. Okay? Liquid plus beta. Amount, thankfully it's already given. The tie line is already there. The tie line is already there. So you know, you walk over here and look down. It already tells you it's 23% liquid, right? And 61 point whatever percent beta. So what's the, again, doing the lever rule, if you want to know the percent liquid, it is this distance divided by the whole distance, right? Which would be what? 61.5 minus 30 divided by 61.5 minus 23, right? That's the liquid. That is 81.8%. Similarly, the other side, looking from the solid side, from the beta side, would be 30 minus 23 divided by 61.5 minus 23. That's the remaining 18.2%. Is that clear? So you're looking from here, right, from this side, it'll be this distance divided by the whole distance, right? I don't want to draw it again and show it to you, but you can go back to the video and see the other one at 2600. You'll know what I'm talking about. Similarly, now at 2665 minus delta T, which is a little bit below, right? So what we did right now was 2665 slightly above, right? I don't know how to show that. Let me erase it, and then maybe I can show it from an erasure. There you go. So we were looking at this point, right? We're looking at, say, that 2665 at 30% there, right? That point, slightly above 2665. Now we are asked to, again at 30%, composition slightly below, right? There. It's a terrible arrow, but that's the way it is, okay? So now we are asked to measure it at that point. How would we do that? It's now slightly below the line, therefore it's in the liquid plus alpha section. So it's phases, liquid, and then alpha. It's the identical one, right? So what's the composition? Composition. Still 23, right? Right? If you walk from here, darn it. If you walk from here, it's just 23, right? What about this walk? What's about the walk towards the liquid? Do you still go all the way to 61, which would be identical to the one that we did above, right? When it was above, we walked all the way there. What do? We don't walk there. It gets stuck here, right? The intersection is right there somewhere, and you have to drop down and take a look. Do you see that? That's around 43%. Right? Let me just draw it, right? I mean, if it's there, I'm just trying to draw it as best as I can. It's right there, right? That's where it intersects. You look down. That's 43%. Do you get that? So I just wanted to point this out slowly. That way, in an exam, you know where this is all coming from, okay? And then, of course, the amount becomes pretty academic in that the liquid side is 43 minus 30 divided by 43 minus 23. And then for the solid, it is 30 minus 23 divided by 43 minus 23. That's 35%, so, 65% liquid, 35% solid. And this way, this is below. Remember, this is alpha. Why is it alpha? Because it is slightly below, right? It's a 30%. It's right here. So it's in this L plus alpha region. Whereas when it's slightly above, it's in the L plus beta region. That's why this is beta. It's above delta T, and it's alpha if it's below. So many students miss that. And what I wanted to point out is that right at 2600, it's almost 60-40, right? But when you go slightly above the peritectic temperature, right, which is 2665, slightly above, it is 80-20, whereas slightly below, it's almost it's completely different, 65-35. Just going from this point to this point, the enormous change in the composition. That's what I wanted to point out. Okay, that's about it. This is how you tackle this. It's already a long video, and so I'm going to cut it here.